Good morning, everyone. Myself, Amit Kumar, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. In discrete mathematics and logic theory, the algebraic structure is a main important topic, and in the algebraic structure, the today's topic is field. As we know that monad, semigroup, group, ring and field, these are the algebraic structure, and these are a given non-empty set with certain operation, and they hold a certain properties. In regards, in field, a field is an algebraic structure that hold two binary operations, addition and multiplication, and following some properties. These properties is regarding to the addition as well as multiplication. So, field. As an outline of this lecture is the definition of field, related properties of field, type of field and application area of the field, and a numerical problem. Field is nothing is an algebraic structure that hold the following properties. Following properties is regarding in a two binary operation. The first one is with respect to addition binary operation, and the second one is with respect to multiplication. So, here we can easily see that in addition and in multiplication. So, any set F in two binary operation is said to be a field if hold the following properties. With respect to addition, hold the closure law, then associative law and identity law, inverse law and commutative law with respect to addition operation. That means we can say that hold the abelian group with respect to addition. In a similar way, with respect to multiplication, hold the closure law, hold the associative law, hold the identity element. Identity element, that means existence of identity element with respect to multiplication. Hold the inverse property and commutative property also. So, we can say that hold all these properties with respect to multiplication. So, this one is commutative with respect to addition, this one is respect to the abelian group respect to the multiplication, and hold the distributive property. Left distributive is equal to the right distributive property. That means the first abelian group with respect to addition, second abelian group with respect to multiplication, and third one is hold the distributive law. Therefore, we can say that if hold the three properties, we can say that F is a field with respect to addition and multiplication. So, one by one we can elaborate it. Here, field and their axioms. Axioms is nothing, is the properties only here, or a certain law that is applied on a given set. A non-empty set having at least two elements equipped with two binary operation. Equipped with two binary operation, already we discussed addition and multiplication. Is said to be a field if the following axioms is satisfied. The following axioms is satisfied, that means with respect to addition. So here we clear mention the properties and their examples. So F1 that means the first property with respect to the addition, a closure law. Follow the closure law. Follow the closure law, that means if any A and B is belong to our F, therefore A plus B, the operation here is the addition. A plus B also belongs to F. So with the help of table, we can easily say that if this type of a structure, because of when we applied A plus A is equal to A, B plus B is equal to B, C plus C is equal to B. So if we have this type of all output is in a F, therefore we can say that hold the closure law. Next, associative. We can easily see that if A, B and C, there are the three elements is in F, then A operation is binary addition, B plus C is equivalent to A plus B plus C. So we can easily see that if hold this property, this is associative law. The third property, existence of additive element. Existence of additive element, in this additive element is known as identity element in respect to addition. In general way, generally in addition, the 0 is a identity element with respect to the given set. So 0 is an element of F. That means when we apply this operation, we see this one is A plus 0 equal to 0 plus A is equivalent to A. So if hold this type of a property, that is known as an identity element is exist in our F. So this one is a 0 is exist in our set F. The fourth one is existence of additive inverse. Additive inverse, that means if A is in belong to F set, therefore A inverse. A inverse, that means here we can write not a inverse here, but A inverse is also belongs to F. So in addition, A have a minus A. A have a minus A as a inverse element with respect to addition operation, and that is equivalent to 0, and that 0 is a identity element. Suppose that A plus minus A equal to E, and E is here identity element. So we can easily see that if A belongs to F, therefore minus E also belongs to F. That is known as the fourth property, existence of additive inverse property. And the fifth one is commutative law. Commutative law is nothing, is hold the A plus B equal to B plus A. In addition, hold the commutative law. So all A plus B belongs to F. That means A plus B is equal to B plus A. If hold these 5 property, we can say that the given set is commutative with respect to addition, or abelian group with respect to addition. And the next one is with respect to multiplication. So we have two properties here, addition and multiplication. So this one is all regarding the addition operation, and the second one is with respect to multiplication. Closure law, follow the closure law. Follow the closure law, that means A is belongs to F, that means A multiplication operation B belongs to F. So hold the closure property. In the same way, associative, that means A dot B dot C equal to A dot B dot C. We can easily see that A dot B dot C is equal to A dot B dot C. So this one is a complete here. So this one is associative. And the third one is existence of multiplication identity element. In general, one is a identity element in respect to, one is a identity element with respect to multiplication binary operation. So if A belongs to F and A dot 1 equal to 1 dot A equal to A, that means hold the identity element. So this one is the 3 law. So and again 4 and 5, because of hold the 5 properties, and again distributive properties. So in a next slide, existence of multiplication inverse element also exists. Existence of multiplication and inverse, that means in a is belongs to F, that means A inverse also A inverse belongs to F, and the operation is A dot A inverse is equal to E. E, that means a identity element, and 1 is a identity element here. A inverse is called the inverse of A, and A inverse, A is a inverse of A is equal to A inverse, and inverse of A inverse is equal to A. Okay, that is vice versa here. Commutative law. In multiplication, A dot B is equal to B dot A. So we can easily see that the 5 properties with respect to addition, the 5 properties with respect to multiplication, and the last 11th property is distributive. Distributive over the addition and multiplication. So left distributive and right distributive are equal. So A dot B plus C, we can see carefully. So we open this bracket, A dot B plus A dot C. This one is known as left distributive. In the same manner, A plus B dot C, that means A dot C plus B dot C. So if the left distribution and right distribution are equal, that means this one is a 1 and this one is a 2. This equivalent to this one and this equivalent to this one. Therefore, we can say that the distributive property hold. So these 11 property hold by any set F with respect to addition and multiplication, then we can say that this one is a field. Here, the algebraic structure, this one, the writing position of this one, is called the field if abelian group with respect to addition, abelian group with respect to multiplication, and hold the distributive law. Therefore, we can say that this one is a field. Okay. So this one is a general idea behind the field algebraic structure. Again, this one is a algebraic structure with respect to addition, algebraic group with respect to addition, algebraic group with respect to multiplication, and this one is a distributive law. Type of field. So consist of non-empty set along with 2 binary operation here known as addition and multiplication. We discussed previous slides. Is closed under these operations. These operations are binary operation, addition and multiplication. The result of combination of element is a domain. Using their addition or multiplication must be an element in the domain. So if they satisfy these properties, hold the field. And the type of field is finite field, algebraic number, algebraic function, and pedic field, and then 5th is rational field. So one by one we can elaborate it. Field that with a fixed number of element is known as finite element. Finite element, that is fixed number of element in a field. F certain is a set and set is a finite set only. So this one is known as finite field. Suppose that R with respect to addition and multiplication, R is a rational number here. So this one is not finite field. Algebraic number field, field that contains the algebraic numbers. Please see this one. Algebraic numbers which are used in polynomials, equation and coefficient of given field. And a finite field is used in coding theory and cryptography's practicals. And the third one is algebraic function. So please see that algebraic number and algebraic function both are different, and if the field contains the algebraic function, that is algebraic function field. Padic function is hold the padic numbers. If hold the padic number, then the padic field is contains. And a rational field is nothing, is a rational number. They use the rational number, that is one is rational field. So here is also a rational field. And the application area, field is essential various mathematics, used in various mathematics field in and a computer science, including number of theories, algebraic, geometry and cryptography. They provide the framework of studying different algebraic structure and have practical approach and used to error correction and cryptography algorithms design. So this one is a application area of a field. This one is also application area of the ring also. So this one is a type of field. Here is an example. With the help of example, we can easily understand how we can solve a problem of field. So here Q and Q with respect to two binary operation is a field. So this one is a field. So prove that this one is a field. So how we can solve this? So when we write the solution of this numerical, at first with respect to addition. With respect to addition, we check the 5 properties. Then again, with respect to multiplication, prove the 5 properties, then distributive properties. If hold these 11 properties, then we can say that this one is a field. So one by one we can, with respect to addition or under addition, suppose this one is a rational number. So sum of two rational number always a rational number. So closure property hold. Hold the closure property. Closed, Q is closed under the addition, therefore. And the second one, any rational number, if A, B, C are the rational number, then 1 by 2 plus 1 by 3 plus 1 by 4 equivalent to 1 by 2 plus 1 by 3 plus 1 by 4. We can easily prove this one. So hold the associative property. So rational number hold the associative property. Existence of identity here in rational number 0 is a identity element with respect to addition. So 1 by 2 plus 0 is equal to 0 plus 1 by 2, that is 1 by 2. So hold this type of a property, that means existence of identity element. And the fifth one is existence of inverse. Existence of inverse, that means if we have a 1 by 2, that is the element of Q, rational number. Q is a rational number here. So 1 by 2 is also in a Q, and minus 1 by 2 is a inverse of 1 by 2. So hold the inverse property. And the fifth one is 1 by 2. 1 by 2 plus 1 by 3 is equal to 1 by 3 plus 1 by 2. Commutative property hold. So all the 5 property we can easily prove that under the addition operation. Similarly, under multiplication, we can prove that the closure property, associative property, existence of identity here is equal to 1. Okay, so 1 by 2 dot 1 equal to 1 dot equal to 1. So existence of identity element. And inverse also, we can prove the inverse also. Inverse 1 by 2 dot 2 by 1, 2 by 1, that is 2 is equal to 1. So the inverse of 1 by 2 is a 2 in case of multiplication operation. So hold the inverse operation and hold the commutative law. So already 5 property hold with respect to multiplication. And next one is distributive property. Distributive property, that means 1 by 2 dot 1 by 3 plus 1 by 5. So 1 by 2 dot 1 by 3 plus 1 by 2 dot 1 by 5. So hold the distributive. This one is the left distributive property. Hold the distributive property. So these 11 property hold by. So we can say that this Q under the operation of addition and multiplication is a field. So these are some examples. We can easily solve the field, and the various examples we can hold. Thank you.